Everyone, welcome to my channel. Today I'm going to talk about clustering. Clustering is the most common unsupervised learning method which is used for data analysis of unlabeled data to finding the patterns or groups. So let's get started. I'm going to cover cluster analysis, types of clustering, k-means clustering, algorithm of k-means clustering, working of the algorithm, elbow method, initial centroid problem, k-mean limitation, and then hierarchical clustering and types of hierarchical clustering. So let's talk about cluster analysis first. It is the finding groups of objects such that the objects in a group will be similar to one another and different from the objects in the other groups. So the basic idea is distance between the data points belong to same cluster should be minimized and distance between the data point belongs to different cluster should be maximized so that we can divide the data points in different groups. Notion of a cluster can be ambiguous. So here you can see there are four figures. The first one is the data points. All are black color. So how many cluster can we get from these data points from this structure? If I want 6 cluster, so clustering will be results of clustering will be like this. If I want 2 clusters, then it will be divided like this. If I want 4 clusters, so basically from this figure we can know that it depends on us how many clusters we want. We have to decide how many clusters we want. Types of clusters. There are two types of clusters, center-based clusters and contiguity-based clusters. Center-based clusters. A cluster is a set of objects such that an object in a cluster is closer to the center of the cluster than to the center of any other cluster. Center of the cluster is often a centroid, the average of all the points in the cluster. So the basic idea of center-based clusters to calculate the distance between the centroid and the data point. Contiguity-based clusters. Cluster is a set of points such that a point in the cluster is closer to one or more other points in the cluster than to any point not in the cluster. Basic idea of contiguity based cluster is to calculate the distance between two data points. So in center based cluster, we calculated the distance between the data point and centroid. In contiguity based clusters, we are calculating the distance between data point to data point. Now the types of clusterings. There are two types of clustering, partitional clustering and hierarchical clustering. Partitional clustering is a division data objects into non-overlapping clusters such that each data object is in exactly one cluster. So in partitional clustering, each data point can belong to only one cluster. On the other hand, in hierarchical clustering, a set of nested clusters organized as a hierarchical tree. So let's understand these concepts with an example. So this is the example of partitional clustering. Here you can see that there are 3 clusters and each data point belongs to some cluster, but it does not belong to more than one cluster. In hierarchical clustering, you can see on the right side, the red ones are the cluster numbers and the black ones are the data points. And you can see this number 1 data point belongs to cluster 1 and cluster 4 as well. That is called hierarchical clustering. So we will understand these both clusterings better one by one. So first of all, k-means clustering. K-means clustering is a type of partitional clustering. K-mean clustering is a type of unsupervised learning which is used when you have unlabeled data. The goal of this algorithm is to find groups in the data with the number of groups represented by the variable k. As I mentioned earlier, k is the number of clusters and you have to choose how many clusters you want. The algorithm works iteratively to assign each data point to one of the k groups based on the features that are provided. Data points are clustered based on the feature similarity. The results of k-means clustering algorithm are centroids of the k clusters and labels for the training data. Typically, the k-means clustering algorithm is used to find groups which have not been explicitly labeled in the data. This can be used to confirm business assumptions about what type of groups exists or to identify unknown groups in the datasets. Once the algorithm has been run and the groups are defined, any new data can be easily assigned to the correct group. So basic algorithm of k-means is, first we need to select the k points as an initial centroids. Then this is the repeat. What steps we are going to repeat? Form k clusters by assigning all the points to the closest centroid. Centroid is the average of all the data points. Then recompute the centroid of each cluster until the centroids don't change. Let's understand this algorithm step by step with an example. Now the working of the algorithm. It begins with choosing the number of k clusters. The k signifies the number of clusters that the algorithm would find in the dataset. Choosing the right k is very important. Sometimes the k is clearly visible from the dataset when visualized, but most of the time this is not the case. We will see about how to choose the right k value later in this presentation. So here in this example, I am choosing k is equal to 2. Step 2. Select at random k points. So here blue and red dots are the random k points. K is equal to 2, so I am going to choose 2 initial centroids. The centroids from the dataset. Centroids, it is not necessary that you have to choose the centroids from the dataset. These can be any points, any random points. Then assign each data point to the closest centroid. That forms the k clusters. Dataset points would be allocated to the centroid which is closest to them. So you can see here, we are going to calculate the distance between all the points and the centroid. And those data points which are closest to this blue centroid belongs to blue cluster, and the data points which are closest to red centroid belongs to red cluster. Now compute and place the new centroid of each cluster. How will we compute the centroid? We are going to calculate the average of all the data points in one cluster and find the new centroid. We are going to repeat repeat these steps until we got the same centroid at the end. So step 5 is reassign each data point to the new closest centroid if any reassignment took place. Go to the step 4. Now choosing the right K. Choosing the right K is very tedious task. There are some algorithms to choose the right K. So I am going to explain here WCSS. Evaluate the K using a parameter WCSS. The full form of WCSS is within cluster sum of squares. The value of WCSS should be very low. The formula to calculate WCSS for 3 clusters. Here WCSS is equal to summation of Pi in cluster 1 and distance between Pi and cluster 1 the square. Here summation distance PC is the sum of distance of points in a cluster from the centroid. Now the elbow method. Elbow method is used to choose the best K value. In this figure, there is no significant decrease in WCSS, so 3 is the best. So these are on the y-axis, these are the values calculated using the formula WCSS I have mentioned before, and on the x-axis these are the number of clusters. So that's how we can choose how many clusters will be best for our data set. So this is the elbow method. There's an elbow shape that forms, and it is usually a good idea to pick the number where this elbow is formed. So I'm choosing number 3. That is the optimal number of clusters. The second thing is importance of choosing initial centroids. What if you choose the wrong centroids and it is leading you to the wrong clusters? Let's see how. This is the example. Here these are the initial data points, and these plus signs are showing the initial centroids. So there are 6 iterations, and you can see iteration 5 and iteration 6 are exactly same and have exactly same centroids. So I'm going to quit here. You can see my data points are clustered very well. But what if I chose these initial centroids? And this initial centroids leads me to this. This is the result, iteration 5. So here you can see I have loose clusters. These brown color clusters, they should be in different clusters, and this green and blue cluster should be merged. So that is the problem of choosing initial centroids. There are some solutions. Let's talk about that. Solutions to initial centroid problem. One is multiple runs. It helps, but probability is not on your side, because you never know when will you get the best clustering. Second thing is K-means plus plus algorithm. This algorithm ensures a smarter initialization of centroid and improves the quantity of clustering. This is very similar to the K-mean clustering algorithm. Only difference is the smarter initialization of centroids. I'm not going to cover this K-means plus plus algorithm here, but you can study on your own if you want. I will show you how to use this K-means plus plus algorithm in my next video of implementation of K-means algorithm and hierarchical clustering algorithm. Third method is post-processing. Post-processing is eliminate the small clusters that may represent outliers. Split loose clusters like these. These brown clusters are loose clusters. We can split them. Merge the clusters that are so close, like these blue and green clusters. They are very close, so we can merge them. So these are the solutions to initial centroid problem. Now let's talk about limitations of k-means. K-means has problems when clusters are of different sizes, different densities, and non-globular shapes. K-means have problems when data contains outliers. So let's understand one by one. Limitations of k-means, different sizes. So here on the left side, the original points. You can see one is the very big cluster and other two are the very small clusters. So if my initial centroids will be only in the big cluster, then clustering would result like this. So this is not a good clustering, because it should be one big cluster and two small clusters like this on the left side. Now the second is different densities. So here on the left side you can see original points. One cluster is very light and two clusters, blue and green cluster, is very dense. So if initial centroids are like these, then these two dense clusters will be merged in one cluster, which should not be the idea. The third thing is non-globular shapes. So you can see these shapes are very weird. Like if I am going to put one centroid here and one here, then result will be like this. So some of the red data points will belong to blue, and some of the blue data point will belong to red cluster. So these clusterings we cannot be the optimal clustering. So one thing we can do, overcoming k-means limitations, choosing multiple centroids, like multiple clusters. The value of k, choose the value of k little high. Rather than 3 clusters, I have chosen 4 and 4, 10 clusters. So that at the end we are going to merging the clusters, and we will get the uh, right clustering. Okay, now let's talk about hierarchical clustering. Hierarchical clustering is a set of nested clusters organized as a hierarchical tree. It is a tree-like diagram that records the sequences of merges or splits. So I already explained that in hierarchical clustering, one data point can belong to multiple clusters. Like it inherits to its parent. Like this 3 data point belongs to one cluster, which is the child of cluster number 4. Let's see how it works. There are two types of hierarchical clustering: agglomerative and divisive. In agglomerative, start with the points as individual clusters. So in agglomerative, each point will be one cluster. And at each step, merge the closest pair of clusters until only one cluster left. So it's like merge sort. There are all the data points will be cluster, and we are going to merge the closest pair of clusters until we get the one cluster. Second type is divisive. We are starting with the one cluster, all the data points in one cluster, and we are going to split them until each cluster contain a point. One other way also you can think, if you mention that I want 4 clusters and you have thousands of data points, then in agglomerative it will merge until you get 4 clusters, and in divisive it will divide until you get 4 clusters. So this is the agglomerative and divisive diagram, and here agglomerative is bottom up approach and divisive is top down approach. And it is very clear from this diagram that in divisive you are going to come down from one cluster to multiple clusters, and in agglomerative from multiple clusters to one cluster. Thank you so much. That's it for this video. Please subscribe my channel so that you can know whenever there is another new video. Thank you so much. And if you guys have any question, please write in comment box.